All right, Algebra 2. So I have two things that I want to go over with you. First thing is inverses. So make sure you're looking at this proof book first, the inverses proof book. So every function has an inverse. If the graph of f of x passes the horizontal line test, then the function f to the negative 1, which is our inverse function, is also a function. You can always write it, it just may not be a function. So f of x is equal to 1/5 x to the third minus 2. The inverse function of that, we will get to how we find that in a minute. However, if I take and pass a horizontal line through each of these and it passes the horizontal line test, then its inverse function, so the inverse function of f of x, will also be a function and is therefore 1 to 1. Okay? That's important when we get talking about how you find an inverse function. So moving on, we're going to look at example 1. So as far as ordered pairs go of functions and their inverses, if I have a point x comma y on my f of x function, then the inverse function just swaps those two things. So x comma y, or y comma x. So if I have the function f of x right here, and the ordered pair is -7, -31, it is just the opposite of that in my inverse function, so -31, -7. So that means I should always be able to figure these out, like if I have -3, -9, and then over here, this should be -3. If this is -15, then this should be a 1, and that should be -15. This must be 5, 17, so this is 17, 5, and then lastly, this must be 9, 33, since this is 33, 9. So I'll leave B for you to try. I don't think you're going to be able to find out what this one is because you don't have any information, and that's okay. So example 2, the graphs of f of x and its inverse function are reflected about the line y equals x. So what that means is if I have the line y equals x, which is this line right here, we talked about reflections a ton in geometry. You were just reflecting over that line. And the way we wrote out that reflection, if you remember, in geometry is you started with an ordered pair x comma y. The reflection over the line y equals x would change your ordered pairs to y comma x, which is what we just talked about in the last example. And basically that's all I do here. I mean, you could reflect them over, but I think it's much easier to just take our ordered pairs and swap them. Like this is currently at -2, 3. So this reflected point will be at 3, -2. Then I can take this point, which is at -1, 1. We can reflect that, so it will be at 1, -1. And then lastly, this point here is at 1, -3. So when I reflect that, it will be at -3, 1 here. And so we get this line, which hopefully to you looks like a reflection across that line. If you're not sure, sometimes I turn the line horizontally and see, like, yeah, did that reflect over? I think so. So again, this is one that I'll leave for you to try. And then lastly, if we have equations of f of x and the f inverse of x, so its inverse function, the way we can find it is to replace f of x with y, because that's what it's equal to. So if I do that with a, we'll have y equals 1/2 x to the third plus 4. Then we switch x and y. So this becomes x, and this becomes y. That's what we've been doing this whole time with each of our ordered pairs and everything. Then we just solve for y, so we need to get y by itself. So first I would subtract 4. then I would have to times by 2 the whole thing. So we would have 2x minus 8 equals y to the third, and then we would cube root. So y, or the f inverse function of x, is equal to the cube root of 2x minus 8. Now, to determine if that function is one-to-one, we have to think about what this looks like graphed, and if it would pass the horizontal line test. And since we don't know how to graph that yet, we're not going to worry about that. So I'll try one more, and I'm going to leave the last one for you. So again, we replace this with y. Then we switch x and y, so this is going to be x. This is going to be y. And then we solve. So the first problem is I have this square root, so I'm going to square it to get rid of that. Then I'm going to add 4. And then divide by 6. So y, or the f inverse function of x, is equal to, I might rewrite this as x squared over 6 plus 2/3, but you don't have to, it doesn't matter. I just divided. So again, I'll leave the last one for you to try, and we can go over those things on Tuesday rather. Now, looking back at our operations with functions really quickly, I don't want to make this video super long, but this was the other proof book that I gave to you, or I had the sub give to you on Wednesday, and we didn't do this together. But it might be good for us to do some of these now. So if I look at maybe example 3, because that one's a little bit trickier. All this is saying is f plus g of x is equal to f of x plus g of x. So I just replace these things as they are because I'm putting x in, and x is already put in here. So this is going to be 10 x to the half plus 5x to the half. Now I can only add if these are like terms, and like terms have to have the same letter, same power, and they do. So we're going to have 15x to the 1/2. If you wanted, you could rewrite that as 15 square root of x, because those things are equivalent, but I would probably just leave it like this. The product of those things means that I'm just going to multiply the two. So we would have 10x to the half times 5x to the half. Now we can multiply whatever we want, so I would multiply the numbers and get 50. And then x to the half times x to the half, we add our exponents, and half plus half is 1, so we're going to have x to the first, so 50x. Now the thing is, then if I took that and actually had f of g of 3, then I'm taking 3 and plugging it in, but since I've already simplified that, I already know that I'm going to put 3 into this simplified multiplication problem right here, and so that would really just be 50 times 3, which is 150. The last thing that I want to go over quickly is the composition function. So if I were to do f composed with g of x, that means I would have f of g of x, and I would first replace g of x, so we would have f of 5x to the half. And then this goes into our g function, which multiplies by 10, and then raises to the half power. And then we should distribute that half power, so we have 5 to the half times x to the 1/4 times 10. And I can't really square root 5, because that's what that says, and I can't really 4th root x, because I don't know how much that is, so I think this would be my final answer, which is kind of weird looking. So hopefully those few examples help a little bit more. And yeah, I'll see you Tuesday. Good luck.